Okay, so let's go through an example of how we might calculate a percentile for a rank order or simple frequency distribution. I've started out by giving you a frequency distribution. Okay, so we have values that have been collected for vertical jump in inches, and we have the number of occurrences or the frequency of occurrence for each of these vertical jump values. The formula for calculating an exact percentile for a simple frequency distribution is taking the cumulative frequency at the raw score of interest, dividing it by the entire sample size or the total number of scores you have collected, and then you divide it by 0 to get the percent. Okay. What is a cumulative frequency? Okay. So I've given you guys some examples here. Our raw scores of interest are going to be 33 and 38 for our examples. So the first thing that we have to do is figure out what the cumulative frequency is. Basically, if you think about the word cumulative, like if you have a cumulative final, it's everything that you've learned prior to that exam that goes into that final, right? So you can think about cumulative frequency in the same respect. It's the frequency at a given raw score plus all of the frequencies that have occurred prior to that particular score. So if we're making a cumulative frequency column, we need to start at the worst score in our distribution. So for vertical jump, the higher you jump, the better your jump is. The lower the jump, the worse. So we're going to start our cumulative frequency at the worst score, which in this case is 26. And in the first cumulative frequency row, it's always going to be equal to the existing frequency of that worst value. Okay, so at 26, we have a frequency of 3. Cumulative frequency is 3. Exactly 3 people performed the worst in this vertical jump and got a value of 26. As we move up our distribution, we take the cumulative frequency that we currently have, we add the frequency of the next raw score in our distribution, and that becomes our next cumulative frequency, right, which is 6. This should make sense, right, because if we added up the frequencies of everybody who performed at or better than, or at or worse than 27, 3 plus 3 is 6. Okay, we add 6 more to that, and we get 12. Add 7 to that, we get 19. Okay, and so on and so forth until we have our entire sample size. So again, start your cumulative frequency column at the worst score. The setup of how these values are organized may not always be the worst scores at the bottom. Sometimes the worst score might be at the top. So just pay attention to the variable of interest and then figure out where the worst score exists and start there. The sample size is always going to be at the last cumulative frequency you calculate, just as a reference. That's a very quick way to figure out how many people are in your sample when you're just given the distribution table. So if we were interested at the percentile for a person with a vertical jump of 33 inches, we could consult our frequency distribution and look at the value 33. We can see the cumulative frequency associated with 33 is 19. And then based on our formula, we take that cumulative frequency, so 19, divide it by our sample size, 25, multiply by 100, and we should get about 76%. I'm rounding to the nearest whole number, so if you got a decimal, you could always present it as, I don't actually know what the decimal is, but let's say it was 76.57%. You can represent it as a percent, or you can say it's the it's a weird way to say it. 76th, add the th on it, percentile. So either way would be an acceptable format to present your answer in. If we did or wanted to know the exact percentile for a vertical jump of 38 inches, we could perform a similar process. If you want to pause the video and see if you can calculate the answer really quick, I would recommend doing so. If we look for 38 on our distribution, we can find the cumulative frequency that is associated with that raw score, so 23, divide it by our sample size 25, and multiply by 100. That would give us a percentile of 92, or the person who has a jump of 38 would be at the 92nd percentile. So simple frequency distribution, pretty easy to calculate the exact percentile. For group frequency distributions, you can see the formula gets a little bit messier. Yay! It is very important that when you are calculating this, you make sure you account for your order of operation. So everybody should know PEMDAS, P-E-M-D-A-S, parentheses, exponents, multiplication, division, addition, subtraction. Okay, that is your order of operation. It's very, very important. Because if you input this wrong, if you're calculating it in Excel or you're calculating it on a calculator, and you input it wrong or the order is off, your value will be very, very different than what the actual answer is. So I've kind of included a legend of what all of these variables mean. X is going to be our raw score of interest. L represents the lower limit of an interval, or the lower bound of an interval. Our intervals are outlined as a group. Okay, so for this particular one, we have vertical jump as our variable again. And we have intervals of 5 inches. So 10 to 14.9, right? 15 to 19.9. Technically, they're 4.9 intervals, but I mean, meh. Okay. So generally speaking, our interval size is 5. The quickest way that you can determine interval size is by taking two adjacent lower boundaries, right? So if I look at the lower bound of this group and the lower bound of this group, 15 minus 10 is 5. You could do a similar thing with upper bounds, so two adjacent groups, right, that sit next to each other. 19.9 minus 14.9 would also give us 5. So there's different ways you can calculate interval size. It doesn't matter where in your frequency distribution you calculate interval size. I usually start at the top, but it really doesn't matter. So either look at two adjacent lower bound or lower limits, or two adjacent upper limits, and take the difference between those two values. L is the lower limit of the interval, so that would be the first value that you see in each group. F in our formula represents the frequency that occurs for that group. So if we wanted, a value that was between 15 and 19.9, the frequency for that group is 12. C, this is a fun one for people to riddle out, is the cumulative frequency of intervals smaller, or of the interval smaller than the interval in question. So let's say that I had a group or a raw score that was between 15 and 19.9. Okay. The cumulative frequency that I would report or would record in my formula is the cumulative frequency of the interval below the group that my raw score exists in. Okay, well, we'll go through an example of this, so it should help make more sense of where numbers are coming from. And then N, again, is our total number of cases, or our sample size. So similar to creating a cumulative frequency column for our simple frequency distribution, for our group frequency distribution, we're going to start at the worst score. So remember I told you the order in which the values appear might be greatest to smallest, might be smallest to greatest. In this case, our worst vertical jump is 10 inches, and our best vertical jump is going to be topped at 44.9. So we're going to start our cumulative frequency column in this cell here. Remember that the first cumulative frequency you measure is going to be equal to the frequency of that first group. So our cumulative frequency for people who can jump at or worse than between 10 and 14.9 inches is 5. We then take 5, add our frequency of our next group, and we get the cumulative frequency for people who can jump at or worse than 19.9 inches. Okay, so 17 would be our cumulative frequency there. Then we can add 20, we get 37, add 25, 62, add 15 to that, we get 77, so on and so forth, and we end up with a sample size of 90 people. So 100% of our sample should be able to perform a vertical jump at or worse than 44.9. Okay, so now that we have this information, we can apply some examples with raw scores of interest. So if we wanted to know the percentile for a person who can jump 30 inches, 30 inches or 30 would be X, our raw score of interest. We would then locate 30 in its respective group. So in this case, it would be in this group here. So formula-wise, we're looking at 30 minus 30, because 30 is also the lower limit of the group that our raw score exists in. I, our interval, we already discussed was 5, taking the difference between two adjacent lower limits or two adjacent upper limits. So in this case, I could say 35 minus 30 is 5. My interval size is 5. So far we have 5 minus 5, which is 0. Divided by 5 is still 0. Okay. We then can multiply that by our frequency that exists in the group in which 30 is located in. So the frequency of this group is 15. So this area was equal to 0 times 15 is still 0. Right? You can imagine this entire numerator is in parentheses if you want to. And then we would add that to our cumulative frequency of the group that is worse than where 30 is located. So we've identified this is where 30 is located. The cumulative frequency of the group worse than that is 62. Okay, because the worst values are kind of going in this direction. So 62 would go where C is. We previously had a quotient of 0, so 0 plus 62 is 62. And then if we divide that value by 90, we should get an answer of 68.9%, or we could describe it as the 68.9th percentile. If you round up to the nearest whole number, we could say it's the 69th percentile. So, hopefully that makes sense. If the numbers that I just spat at you did not make sense, I do have the order of operations listed in the notes section on this slide. We can do a similar process for calculating a percentile of a vertical jump of 22 inches. So again, we locate where 22 is in our group frequency distribution, which would be here between 20 and 24.9. So 22 is our raw score of interest, minus the lower bound of the group 22 is located in, which is 20. So far we've got 22 minus 20 divided by our interval size, which is 5. You calculate that out, multiply it by the frequency of the group that 22 exists in, so 20 would be the frequency that goes here. And then we would add the cumulative frequency of the group that is worse than where 22 is located, which would be 17. Okay, because 22 is in this interval. Cumulative frequency of the group worse than that is 17. So that would be C. And then we divide by our sample size. When we put all of that together, you should get the 27.8th percentile or 27.8%. In other words, a person who has a vertical jump of 22 inches performed better than 27.8% of the sample that was collected. Okay. I've got some practice problems for you guys to work on. So a different variable for this is peak power measured in watts. I've given you the general layout of the group frequency distribution, some raw scores that you can calculate your percentiles for. It's up to you to create your cumulative frequency column. And again, all of the answers and the order of operations have been notated in the note section of the slide. There are some problems in calculating percentiles, or some limitations, if you will. They give a poor evaluation of improvement. So if you were looking at, let's say a vertical jump, and you want to see like, well, how much, let's say a person had a baseline value of 34 inches and they went up to 36 inches. If you were purely using percentiles to evaluate this performance, the percentile associated with 34 inches, we'd have to calculate that, right? So let me fill this in really quick, just so we have everything on the slide. Okay, 34 is associated with a cumulative frequency of 10, right? If we built our frequency column from the bottom up, worst score to best score. And this is a simple frequency distribution similar to our first example. So if we took 10 and divided it by our sample size, which is 31, okay, we would end up with 32%. Now, if we did the exact same process for 36, said 24 divided by 31 times 100, we get 77%. Okay, so a difference of 2 inches in this case is equivalent to a 45 percentile difference. But if we looked at a 2-inch difference between 36 and 38, let's say, now we're looking at a jump from the 77th percentile to the 90th percentile. That's only a 13% difference in percentile ranking. So the equivalency between improvement in terms of the unit of measurement that you collected does not often translate into the improvement or the increase that you see in the percentile ranking. So we don't really, I feel like you shouldn't really use percentiles to assess improvement just because of this particular limitation. But also you can think about how percentiles are laid out within a normal distribution. So everything is going to be more clustered towards the center, and then as you get out to the ends, you're going to have kind of more and more space between percentile rankings. So if that helps to visualize this in another way, that's great. But yeah, so this is percentiles. Again, I would recommend that you go back and do the practice problems on your own, especially for the group frequency distribution. Students usually grasp the simple frequency distributions pretty quickly, but the grouped ones take a little bit more effort, especially in making sure you write out and you're calculating everything correctly. So double check your answers with the notes section in the PowerPoint